Before we start, we would like to say a huge thank you to our weekly giveaway sponsor, Avatao. For the next few weeks, we will be giving away spots in the OWASP DevSlop organization on the Avatao platform. Avatao is an application security learning platform that helps engineers build secure software and allow IT leaders to have greater visibility into the strengths of their teams. Hello, everyone. Welcome to the OWASP DevSlop show. Today, we have another great show for you. And before we start, let me introduce you to my co-host. Today, I have with me Nikki Becher. Just a second. Hi, Nikki. How are you doing?
Hey, guys. How's it going, Nancy?
Excellent. So, OPA
so steamy over here on the East Coast.
Same here in Ottawa. Today is Automating Cloud Security with OPA, as they call it. Are you familiar with OPA? You excited about this today?
Yeah. Open policy agent. Totally.
Yes.
It's going to save us all.
Yes. So our guest today is Josh Stella. One of the primary attack vectors in the cloud era is cloud misconfiguration. And our guest today, Josh, CTO and co-founder at Fugue, he believes that manual processes are no longer sufficient and that policy as code is mandatory to secure cloud environments successfully. So Josh will introduce us to the Open Policy Agents CNCF project and demonstrate how it can protect our cloud. So here we go. Hi, Josh.
Hi, Nancy. Hi, Nikki. Great to be here today. Thanks for having me.
Hey, Josh.
Yes. So what do you have planned for us today?
Well, I thought I'd do a few slides. I'm going to go through them pretty quick. And then I'm going to spend a fair amount of time in the browser and the code editor and just show you around Open Policy Agent, some of the tooling out there, how it applies to cloud security. Nikki, I caught your sarcasm. Whenever anyone in computing says it will save us all, I know that's sarcasm, and correctly so. But it is pretty cool, and
it is.
It has its sharp edges, right? But it also has a lot of power, and I think, to me, one of the most exciting things, having been around like the kind of intersection of development and security for a few decades now, it's the first thing I've seen that could become a standard approach to policy as code, and that's actually good. So. Yeah, that's what I had planned, and hopefully it's real interactive, and people interrupt and ask questions and tell me if I'm full of it on something, and we'll keep it interactive, I hope.
Yes, we got some people already there in the chat. Feel free, people, to just ask your questions. We'll try to find a good spot in Josh's presentation to interrupt him and ask him the question. Nikki's here with me.
Yep.
So let's get started. Do I share your slide right away?
Yeah, let's go ahead and do it.
Awesome. Here we go. So
if you see me looking this way, it's because that's where my screen, StreamYard is, but so I apologize if I kind of do that reflexively. All right, let's get into it. I do want to go through a few slides to just talk about what is misconfiguration risk in cloud. I know we've got a highly technical audience, and I'm not going to bore you with this, but I want to walk through it a little bit to explain how policy as code is both needed and can be injected into every part of the SDLC, not just static code analysis of infrastructure as code templates, which is how most people are thinking of this. You do that, we do that. I'll show you comp tests and some other things too that do that. But you need it all the way through the SDLC, in my opinion. And I'll give you a little tour of the ecosystem. This is not a Rego class. I will show you some Rego. Rego is the language of OPA, but I'll point you to a few things to get started with. And then, of course, we say Q&A at the end, but go ahead and be rude and interrupt me. All right, cloud misconfiguration is like the main attack vector on cloud. Prior to founding Fugue, I was at AWS, focused on national security kinds of applications. This is all I've been focused on for almost a decade now. And we see it time and again. And actually, Nikki and I were chatting about this before we all got online, about just like the tremendous complexities of things like IAM. And how do you know if you have a misconfiguration? It's quite hard. Here, Gartner's saying, it's all the customer's fault. Nearly all successful attacks on cloud result of customer misconfiguration. While true, that I think is a little pejorative to cloud customers. It's a little unfair, because the way these systems fit together, and particularly from a security perspective, it's remarkably difficult to get everything right. And in fact, a lot of times you think you have it right, and there are vectors that the hackers are using. We did a big survey of hundreds of folks operating at Cloud on Scale, asking them about what they were worried about. I was actually really happy that the #1 response was IAM, because the news would have you think that public S3 buckets are the biggest, baddest, scariest thing out there. They're bad and scary, but most people know how to check for those now. It's really surfing the IAM network, finding bad ports through security group rules to things like orphaned infrastructure that then give you access to IAM roles associated with that. The hackers are sophisticated. And what pleased me about this result from the survey is that the defenders are sophisticated too, and that's a good thing. All right, so why do a lot of these misconfigurations go missed? And by the way, what I'm going to be showing you in this is how OPA can be used to find misconfigurations, many kinds of misconfigurations. But I want to talk about why people are missing them now. The compliance standards like CIS and NIST and PCI and SOC 2 are pretty behind the times. And so the security teams are often looking to those to be helpful ways to understand what's dangerous, but they're not fully up to speed themselves on the vectors hackers are using. And so the result of that is you tend to be to kind of fly blind to a lot of these misconfigurations, and therefore they're very common. Also, your cloud configuration is probably constantly changing. If it isn't, it probably should be, because that's one of the major benefits of cloud. So it's kind of like needles constantly appearing in a haystack, or maybe haystacks appearing constantly with needles in them. Hackers have, the way they're finding targets has changed. The kind of classic, movie Hollywood version of hacking, where like we're going to target, Fugue or Sony. And Sony is the one where this really happened, right? We're going to target this organization, and then we're going to look for vulnerabilities, or do, Twitter, right? A week ago. It does still happen that way, but far more common. Even some very, very high profile cloud breaches were actually not done that way. The way they were done is automation was being used by hackers to just look at anything that appeared on the internet and compare it to known vulnerabilities. Okay, and this happens. The figure I've heard from the best source that I trust on this is that you've probably got an average of about 7 minutes from any IP, any public internet-facing resource going online for it to have been scanned by at least one bad actor, and they're doing it all the time. And that gives them a shopping list to go and say, oh, Sony's on this list. So instead of targeting the organization, therefore, you do not have two things. There is no security and obscurity, no matter who you are. And two, you don't have any time, right? You do not have time for humans to fix things, because the hackers are pretty much fully automated. I'm pretty sure everyone knows this here, but I'll just cover it really briefly. So in the old days, we would kind of very slowly design infrastructure, because designing and building infrastructure meant like, procuring large quantities of very heavy equipment that we would rack and stack. And so we would go through, a competitive cycle with vendors to buy switches or firewalls or servers or whatever. And then it would be manually built. It would be pretty static. and then applications would get kind of shoved into that plant that was designed. Well, that friction gave folks time to manually make decisions, human decisions. I remember when I worked in kind of national security stuff, even before AWS, we would have these big Excel spreadsheets that we would all sit around in a change control board and decide what was safe. But in the cloud, that's flipped upside down because of software-defined infrastructure, which is a wonderful thing, and I love it. It makes everything highly dynamic. I built yesterday, not today. Today's Sunday. I took the morning off, but yesterday I built a global network in about 10 minutes. And I'm talking about a set of VPCs across multiple regions, and that was me executing effectively one command line that triggered a bunch of scripts. So that was never possible before. And that means that your infrastructure, the friction is gone, right? The checks and balances, if you will, are largely gone. A human cannot, or a change control board cannot easily get their hands around the rate of change in cloud, even if you're doing infrastructure as code. That is not a silver bullet for this. It's helpful, but it's not a silver bullet. So, but what I think a lot of folks miss is what a huge opportunity cloud APIs provide from a security perspective. Because I'm a software developer and software architect. I'm not a data center, hardware guy. I mean, I've done some of that, but that's really what I've focused on. And I think we're going to have the most secure systems we've ever made for the following reason. Because the configuration of our quote unquote infrastructure, of our cloud configurations, is API driven, we can use computer science. We can use software engineering. We can use automation because it's all exposed in consistent APIs. And that means we can actually reason about it, and we can tell our very, very fast and completely dumb and non-intuitive friends, computers, to go make sure things are right all the time, right? That's now feasible. It was not feasible before. So developers are really now building and modifying their own infrastructure environments. All right. So we think at Fugue, I personally think that the right answer to this is policy as code, because you have a lot of movement and you have a lot of stuff. A lot of our customers at Fugue are like, hundreds of AWS accounts or more with, many, many, many tens of thousands of resources. I mean, we're doing billions of policy evaluations a day with policy as code in Fugue. And when you're operating at that scale, you really need automation. So I won't belabor the point on data center v cloud. I'm just going to say engineers can now assert security and policy control over infrastructure, and I mean software engineers, where in the past that was a very human, direct, hands-on manual enterprise. And as Nikki and I were talking about before this, that doesn't mean it's easy. It means it's possible. Okay, a little bit about policy as code briefly, and specifically Open Policy Agent. The way I think about policy as code is it's like but different than general purpose programming languages. So a general purpose, but it has similar tooling, and that's key. So a general purpose programming language, you're typically expressing logical functions. You have data, you want to operate on it. Maybe it's Lisp and it's all data, I don't know. But generally your compiler or your interpreter and your tooling are helping you know if you're doing things that are logically correct and sensible, okay? Policy as code has a different focus. And I would argue that OPA has taken the right approach with not doing a general purpose language for it. General purpose languages were not designed for this, and it is a different domain. However, we want policy as code to act in a developer-friendly way, which means giving error messages. So the same way, and guiding us to correct solutions. So the same way that if I, miscast or fail to cast a variable in a calculation, my compiler or interpreter will tell me, don't multiply that string by that floating point. That's probably not going to do a good thing. Policy as code will return an error to me saying, don't leave the default security group on your VPC network in place and open to world on egress, because that's not a good thing. So the idea here, at least to me, is to provide developers and engineers the same kind of information they're used to working with through trial and error and learning with programming languages with policy. All right, a little about Open Policy Agent. We're pretty early adopters of this. We've been working with OPA for a couple of years. We actually have a bunch of patents in policy as code at Fugue, and had written our own declarative language. And then because there just wasn't a good thing out there. And then we ran across OPA a couple of years ago, and it's like, hey, this is pretty good. It's actually very good. And now with CNCF getting involved, it's taking off, and I'm extremely excited about that. The way you write policy in OPA is using a language called Rego. I don't know if it's Rego or Rego. I call it Rego. Call it whatever you want. It's a derivative of a language called Datalog, which is a query language. So the way to think about writing OPA policies is more like SQL queries than C code. It's not an imperative language. You're going to be making declarations in the form of queries and returning results. And that can be a little alien, but I think if you've probably worked some with SQL, think of it more that way than like an imperative or an object-oriented language or something. Now, it functions against JSON data structures. And for better or worse, we've all decided as an industry that JSON data structures are how we're going to communicate nearly everything. So that's awesome, because that means you can use OPA for nearly anything. I used to call it OPA. The folks who wrote it call it OPA, so I've adopted that. And there's a bunch of use cases for it. I mean, there's a use case, like anytime you need to check for correctness against JSON using a declarative query, OPA might be your tool. But what we're going to talk about today, and what Fugue really focuses on and spend our whole lives doing, is about that cloud configuration, that cloud security space and how this works. But OPA can be used for a wide variety of use cases, which is a good thing, because it means learning it is probably a better career skill than some, whether it's open source or proprietary, some little project that's just focused on one space. And there's getting to be a pretty good tooling ecosystem. I'll show you a couple of things that we've written, but more, and some we haven't, but some is coming out all the time. I'm not going to belabor proprietary versus open. I think this group prefers open, as do we. Yeah, one major point. You don't need to be doing infrastructure as code to do policy as code. I would argue that no matter how your cloud infrastructure is made, you should be using policy as code right now against the running resources in the environment. You should also be checking your infrastructure as code, but yeah, I'm sorry, there was a question?
Yeah, no, just a question. So just to drill in on that a little bit more, if that was where you were at as an organization, how would you begin that process of trying to apply policy as code on something that isn't yet infrastructure as code?
Yeah, so I don't want to make this product pitchy. We do that. I will tell you, if you want to do it yourselves, how you can. We do it for free with Fugue Developer. The way you do that is you interrogate the APIs of the running cloud infrastructure, and you collect all of the configuration details into a JSON file or a collection of files into a JSON data structure, and then you run that data structure against Rego rules.
Got it. Okay, so you basically reverse engineer the infrastructure as code.
Kind of. Okay. You know, this gets into some interesting subtleties, and we could probably go down a bit of a rabbit hole here, but I'll go a little ways. When you look at an infrastructure as code template, what you're looking at is an extremely shorthand version of what's going to happen when it executes. Okay, so one example: when you build a VPC network, you have, whether it's CloudFormation or Terraform or Ansible, you have a certain number of parameters you can put into an infrastructure as code template that you can check the template for to see if those things are mistakes or not. But when you execute that, what you get on the cloud provider is a bunch of other stuff too, for free. And it's awesome, right? But you don't know if that stuff's correct. So I used the example earlier, you get a default security group on AWS with egress to world. That is never defined in your infrastructure as code template. So you're not exactly reverse engineering the infrastructure as code. You are using that data structure to interrogate the result of running the infrastructure as code. Does that make sense?
Yep, I get it. That was a good overview. I appreciate it. Thank you.
Cool. I think I'm going to just jump in now. That's enough. Let's start with, where do I put my web browser? Okay, we're going to start with just, high level, what's OPA? I know some of you are probably real familiar, so bear with me. And we're going to get into a pretty sophisticated project written in OPA, which is an open source project, and some other things too. So this is the openpolicyagent.org website. And they will tell you some things here. It is declarative policy. So here it tends to be, in our experience anyway, to date, primarily used in Kubernetes. And a lot of times when you look at who are using it at big scale, aside from Fugue, it's folks like Netflix and Pinterest. Their use cases, at least that I heard about when we were doing talks, was really around evaluating, essentially authentication of microservice transactions. Like, can this microservice do this transaction to this other microservice? So more on an event basis in a mesh. But it's really very flexible and powerful. It is declarative. So you can see here, but it's a real language with real language features. So you can do packages, you can do comments, you can do all kinds of stuff. And I'll show you some of this in more sophisticated ways later. But here this is a deny, right? And it's just evaluating, in this case, input request kind for a pod. But
Josh, I'll interrupt you just a second, just to make your screen a bit bigger, because I can't see the writing.
That better?
That's better, much better. Okay. Thank you.
My code editor has much bigger text, but that's their website. The main thing I wanted to show you here, I mean, this is standard kind of marketing-y stuff, but this right here. So one thing to understand about OPA, what you're doing, no matter how you're using it, is you're evaluating JSON data structures in memory against rules. Okay. So that might be in the case of, what Pinterest are doing, can this microservice make that call to this other microservice by interrogating the request as it comes across the network between the services? In Fugue's case, it's exactly what I described when Nikki asked about how to evaluate runtime infrastructure. We go collect all the data on your infrastructure and then evaluate it using those rules. It has two run modes. OPA itself does. One is as a daemon, and one is as a library. And this is intelligent design. This is really good design, because depending on your use case, you might want to run OPA as a service, right? Run it as a daemon, put it in a sidecar, stand it up in whatever, and hit it over the network. In our case, we're running so much evaluation so often that we actually just bring it in as a library, which of course is doing, in the same executables context in the operating system, the evaluations, and so is much, much faster, but you have a little more maintenance to do in terms of making sure your policies are consistent across everywhere it is. But just standard stock downloadable OPA, you can do either way, which is really cool. There's pretty good tooling out there. There's good support in things like VS Code, which is what I'll show to you today. If you're an Emacs person, it's pretty good. I'm an Emacs person, but more VS Code with Rego, I think it's better. It does come with a CLI and a REPL. VS Code is better for Rego. It does come with a CLI and a REPL. And if you're a REPL fan, you know what that means. If you're not, it's a really good way to learn a language and to do development in a highly iterative way. I'm going to show you in a little while what we think are even more powerful tools than what come with it that are totally compatible with it. Yeah, so that is at a high level. I do want to spend a little time on its policy language. I mentioned earlier that we at Fugue spent years developing a lot of intellectual property and actually wrote our own compilers for pure functional policy languages and so on. And then we switched to OPA. And part of the main reason we did that is we saw a potential industry standard, and we think that's good. De facto, not standards body standard, but it's open source, it's part of CNCF, people are starting to use it lots of places. So we like it when things like that happen. But the other reason that we were comfortable doing that, because actually 2 years ago, not many people were using it, is it's quite good. It's thoughtfully designed. So I mentioned earlier that Rego is essentially an extension of Datalog. And if you're not familiar with Datalog, it was sort of a alternative to SQL and is still used in some things like graph databases and so on. It is declarative. You are going to find that it is terse. So don't let that intimidate you. Doing simple things in Rego is super easy. So I'll just show you one example of a simple thing in Rego, so you don't get scared off. All right, so this is part of a project I'll show you in a bit. Make it even bigger. Does that look okay, Nancy, Nikki?
Yeah, I'm seeing it.
So this is a simple rule that's part of a project we have called Regula. And what Regula will do, it's on GitHub, it's open source. It will evaluate Terraform plan files, which are the interstitial step that Terraform has between a template, which is very incomplete, HCL template configuration file, and actually doing an action in the cloud. So what you do with Regula is you tell Terraform, go ahead and show me what your plan is. And we've got GitHub actions for this stuff too. And then Regula will use OPA to go and examine what that Terraform action would be and give you warnings and denials if dangerous things are happening. So this is really kind of it here in terms of the functional code. So what is this rule doing? It's checking to see if the enable key rotation is turned on for KMS, for particular keys. So let's walk through it real quick. We've got a package here. That's good. If you've worked with kind of pseudo languages that don't truly have things like packages, you know that that makes your life really difficult when you get to real substantial bodies of code. We're just defining here a couple of constants. We're saying what is resource type? We're passing a string there. And here we're mapping to a set of controls. That's because of how Fugue and Regula and all the stuff we work on operates. We're trying to map back to things like CIS benchmarks. So we can put right in that policy which CIS benchmark, and then we use our own enumeration as well to keep track of our rules for lots of reasons I won't go into. Now, this is where the rubber starts to hit the road. We're just saying the default allow is false. Okay, so meaning deny. The default allow is false. So we're using allow, or OPA uses allow as a way to say whether something passes a policy rule or not. And we're saying by default, it doesn't. But we have an allow function here that's saying if the input enable key rotation equals true, because this says allow, that will allow it. So I mentioned it's terse, but I actually think it's pretty easy to wrap your head around too. Okay.
So quick question from the chat. Now that you've just described a rule, are there other open source policy sets that people can use? I guess I think the intention there is other Rego rules that you could download that are open source that you can just ready to use?
Yeah, so I'll show you two real quick. That's a pretty good segue. I mean, we put out a big blob of them in Regula, so that's just github.com/fugue/Regula. And we've got a bunch for like AWS, GCP, Azure, etc. I'll show you another project, which is part of that OPA themselves, the Open Policy Agent, are doing, called ConfTest. ConfTest is less about big collections of Rego rules and more about using those rules to check against different kinds of configuration file misconfigurations. It's mostly a Go project, but there is some code in there. And by the way, these two things are totally compatible. So with Regula, there's, if I just do a search here, yeah, so you can run the big pile of rules we have in Regula using ConfTest as well. I hope that's not confusing, but that's one of the nice things about open source stuff. So I'd point you to ConfTest too. Most of the at least I strongly suspect there are other kind of piles of Rego out there in open source world that you could look at. In the cloud security part of this, cloud security in terms of cloud configuration, what we mostly see in open source projects are like libraries written in Python and even other DSLs that didn't catch on. So I'm not aware of any other big packages of OPA rules of Rego for cloud configuration specifically other than Regula, but they may well exist, and I may be unaware of them. But you will see a fair amount of OPA and Rego out there if you poke around. It's pretty much all on GitHub. I think some of the bigger adopters, yeah, if we go, let's go to their GitHub real quick. This is probably a good place to look for things like that. So who's using this thing? Atlassian, microservice API authorization, similar to the Pinterest use case. Biznode, BNY Mellon, OPA as a sidecar to enforce access control based on external context coming from AD and other internal services. So it's another authentication, looks like another authentication, kind of transactional authentication use case. Capital One, they gave a talk along with me at that same conference. They are checking things like Kubernetes clusters with OPA, but this might be a Goldman Sachs, Cloudflare. We're in here. These might be good places if you go to their the OPA GitHub and look at the adopters to get clues on where to look for other folks that are doing it.
Yeah, good point.
Any other questions so far?
No, I think we're looking.
Okay, cool.
Yeah, we can keep going.
So I would start right here. It's not a big language. Rego is not a big language. It's a small language. It's very black boxy, which in this case is good, right? It's not imperative code. You're making declarations and then you're leaving it to the OPA runtime to optimize those. Just like when you write a SQL query, you're not telling that database engine exactly what to do when, right? You can come back with an execution plan where it can tell you. Rego doesn't really have that yet. OPA doesn't have that. But it's fast. I'll tell you, for most use cases, it's plenty fast, and you shouldn't have to worry about that stuff anyway. So that actually contributes to it being a small language. Datalog's been around for a long time and has done some really powerful stuff. And I think that they have kept the spirit of Datalog. And unlike a lot of kind of open source, I mentioned like Python libraries and DSLs that are super half-baked pseudo languages, this is serious stuff. Like there is good computer science behind what is being done here. And I think that's important because if you're not a language designer, you shouldn't be designing languages. I'm not a language designer. We have some amazing language designers at Fugue, and I respect them, and compiler writers and things like that, compiler programmers. It's its own domain. And what I think OPA did really well here is leverage an existent and very solid technology in terms of a language and implementation of it, in order to build on the shoulders of giants rather than kind of build up from something half-baked. So I would start here. It's going to go through your basics, just defining, everything in Rego is, well, almost everything in Rego is a rule. It's going to go through scalars and all that. They do a pretty good job with this. But I want to introduce you now to another open source project that we put out there, which is called the Fugue Rego Toolkit, or Frago. Frago is also on GitHub. It's just github.com/Fugue, which is FUGUE /Frago. And the reason we wrote this, there are two reasons we wrote this. One is we wanted things like breakpoints. We write a ton of Rego. Not only do we do billions of evaluations a day, we do them on hundreds and hundreds of rules that we've written. And some of these rules are, I'll show you in a minute, even in Regula, which is a small subset, very sophisticated. And we wanted real programming tools. We said, hey, it's a real language. Let's have real programming tools, breakpoints, etc. It comes with a REPL. It doesn't matter if you're using Fugue or Regula. If you're doing anything with OPA and Rego, you can use Frago. It's totally compatible. Anything you write in Frago will run in OPA. So it's not a different language. It's just tooling to help you do Rego. So my suggestion would be to start here and to download Frago, because it's going to make your life easier, and learn it in the REPL. Just experiment in the REPL, and it's going to walk you through some pretty basic stuff, right? All the way up to more sophisticated things. And you can get very sophisticated and powerful in Rego. One of the things that I love about it is kind of one of my guiding principles when selecting programming languages that I like to work with is I have two criteria, well, among many, but two of them are, is it really easy to do the simple thing? Is hello world really easy? Is it easy to kind of grok how this thing works? And I would argue that I'm showing you right here, this is pretty easy. But can you do extremely sophisticated and complex things when you need to? And sometimes those are at odds. And I'm happy to report that with OPA and Rego, they are not. Both are there. So I would start here and with Frago. Let's jump into a little bit of what Regula is all about, because I've kind of gone down the rabbit hole of Rego and the language in OPA. So at Fugue, we use OPA for really two use cases, although they're strongly related use cases. One is checking pre-deployment infrastructure as code, right? And we do that in a completely open source way through this project called Regula. What it is going to do is you can, right now it's just Terraform. We're going to add CloudFormation. I can't give you a date on that, but it is coming. And it works against different cloud providers. And then we have a bunch of CIS benchmark rules that we've defined in OPA. So if you run Regula, and you can do that locally, all Regula is really is a Rego library, which is 99% of it, and a couple of handful of shell scripts and a GitHub action. So it's mostly the Rego library. That's where our focus is. Things like conftest already exist, and conftest can just inherit all the rules we've put in Regula, okay? So you can run it locally. You can run it using a GitHub action that we have published on the site. And what you're going to get are things like this, restricting instances to a whitelist of instance types. So you may not want folks running like super expensive GPU instances. Requires IAM password policies with a certain minimum password length. That's a simple identity and access management rule. You might have region restrictions, etc. So we've got a bunch of those, and then what Regula will do when you run it is it will return to you whether or not, I'm trying to find where we put it, and I'm not finding it right now, but it will return to you when you run Regula, and most of the folks who are using this are doing it in CI/CD pipelines in an automated way. So you would have a Terraform, HCL configuration file. You get to the plan phase, then your CI/CD pipeline either calls our GitHub action or has Regula running locally and checks that prior to even going to dev against whatever policies you've selected in Regula. Okay, and you can use it all the way anytime you're evaluating a plan file. I would argue that by the time you go from dev to stage or test or whatever's next in your pipeline, you should have fixed everything before it gets past dev. That's my own position. All right, I want to keep track of time here. But I said earlier, and I'm just gonna touch on this briefly and come back to it, that it's important that you run policy as code, not just on infrastructure as code. And this is where OPA is so cool, because the same rule that you can run in Regula, you can run, and I'm really not trying to make this product pitchy, but the only product that does this is ours, so I have to show it to you in ours. I'm briefly going to do that. Everything I'm going to show you right here is available for free forever in a developer tool. The only reason it's not open source is it's a SaaS. So this is our this network diagram is something that we create, and then we do OPA evaluation. So in this case, the same OPA rule that you're running in Regula can be run against the running infrastructure. Now this is really important, because if you're using different interpretations of policy, and by the way, if you're using different policy as code for a given policy, right? You have a policy which is a set of intentions like SSH not open to world or whatever. When you interpret that, when you write that as policy as code, if you have to write it twice, they're never going to be in agreement. So what you really want, not as a collection, maybe on an individual basis, they will be for some time, but in sophisticated cases, even that is hard. But over time, they're going to diverge, and that's really bad. So the beauty of OPA for cloud security, in my opinion, is you can use it all the way through the SDLC and have one consistent policy as code expression. So in this case, we're just saying that same developer feedback, and I'm showing it to you in a GUI, but this can come back via API as well for CI/CD integration. Like the listener source protocol should be encrypted. Cross-zone load balancing should be enabled. All that is being done in this with OPA, in this case, after it's been run. So how would you do that in a CI/CD pipeline? Let's just talk about dev for 1 second. If you're using Regula with Terraform, we're going to tell you at the plan stage before, so Terraform does a plan and then an apply, and you can stop it at that point. And Regula will tell you at the plan phase the stuff Regula can tell you, right? It'll say, hey, wait a minute, you don't want SSH to world. But then once you do the apply, you can trigger the API from Fugue to run the same OPA rules, and actually more, because you can detect a whole lot more post-apply against that dev environment automatically as well, and get the similar error messages back, and ones that always agree, right? You're going to get more back when you use OPA against the running infrastructure because of all the side effects of cloud APIs, but you won't get disagreement, right? It's what Regula will detect is therefore a subset of what checking after deployment has detected. This is why you can do policy as code now, whether or not you're doing infrastructure as code, and also in every case I've seen, even when folks tell me everything we do is infrastructure as code, I have never seen that be true in my career. I've never seen it. A lot of people have told me that. We do drift detection with our product, and then we just show them actually all kinds of stuff is going on you weren't aware of, because those APIs allow mutation. So I believe it's extremely important to have policy as code through the entire stack, whether or not you're doing infrastructure as code. The beauty is if you're doing infrastructure as code, you can use policy even sooner in the software development lifecycle.
Right. So you're saying there that if somebody had gone into the console and did things that were, I don't know, whatever, not through a script, just manually made changes to assets in the cloud via the console, that at some cadence, Fugue would detect that because it's constantly querying the cloud API and then would apply the OPA policies that you apply in a preventative way in now a reactive way. And you'd be able to sort of like get consistency across the reasoning of those two points of your perspective.
Exactly. And and I would argue, I mean, if you've ever go try to write the same program in, I don't know, Go and Java, and then maintain it for 10 years.
Right.
It is hard. Humans are bad at that. So yes, exactly what you said. You want that same OPA rule to apply pre-deployment and then to be constantly leveraged post-deployment. And by the way, they might have gone into the console, but it also could be like a Terraform run from somewhere outside the CI/CD pipeline.
Right, totally. Yep.
Or an application. I mean, there are tons of apps that mutate the cloud infrastructure they're running on, like baked in to the Java code or the JavaScript code through SDK. Yep. So cloud gets complicated.
Yeah, somebody ran the CLI through an EC2 instance and boom, yeah.
Exactly. It sounds like you've done this. Okay. Sounds like
I just wanted to know, do you need, you're catching different things at build time and at runtime. You want to keep the same rules that you create at build time, at runtime. I got that. If you're catching different things, do you need more rules when you are at build time? Do you add some?
It's a great question. What we've learned by doing both is it's more the other way around.
Okay.
You have more rules in runtime because at pre-deployment, there's a whole bunch of stuff you can't see. So even a Terraform. So if you think about what's in it, I use the example of like the VPC default security group, which is an API side effect. That's one issue, right? Like on many of these cloud APIs, it is so much easier to build something than to tear it down because there's this cascade of side effects in these APIs. They make, routing tables and all kinds of NACLs and whatever else. I'm just poking at VPC right now, but lots of things are like that in cloud. So you can only look at what's in the source code, which is a shorthand. That's one issue. The other issue is in any mature infrastructure as code environment, you have many different sources of truth, by which I mean CloudFormation stacks or Terraform state files or state repositories, and they interact. And a lot of what you search for when you're really looking for security issues are things that cross the boundaries of what you've made in one CloudFormation stack and another, or in one Terraform state file and another. And therefore, at the infrastructure as code level, in our experience, you can only catch about 20 or 30% of the dangerous stuff. The runtime is where you have a whole lot more rules because you have the complete picture. I hope I answered the question you asked.
Yes. And how many times would you run, would you do those checks at runtime? Is that once a day? Or does it run constantly?
Yeah, so you want it to be highly configurable. You can't just rely on the event-driven stuff like CloudTrail and the equivalents on Azure. You really need the whole picture. So you do need to do a full scan or interrogation at some frequency, but it depends on the use case. So If you are wanting to come in the morning and check and see what your compliance posture is, a lot of our customers will run like a daily compliance scan across everything, and then we'll run like the evaluations of the stuff they're most worried about changing, like IAM and VPCs and security groups every 5 or 10 minutes.
Okay.
CloudTrail promises 15, well, it doesn't promise anything. It says you should bet on about 15 minutes. Sometimes it's like a second, and sometimes it's like 9 hours. Yeah, it depends on, you have to understand the use case, because when you're consuming a cloud API, in other words, when you're doing like a describe call on an EC2 instance, in AWS on a account and region basis, there is a quota that you are consuming before you hit an API throttle. We've got 10 minutes left. I do want to show a little bit of advanced Rego. So just to convince you, I hope, that you can do very sophisticated things in this language and with this tool. So this is a nice, simple one, but we've actually kind of lied to you. We've made this much easier than if you were to try to go do this against the Terraform plan file yourself, because Terraform plan files are extremely messy and unnecessarily, I mean, this is a nice, succinct way to say this. So we wanted that nice, succinct way to say it. And therefore, we built a lot of stuff into Regula in particular, and you can go learn from this. You know, folks are asking about examples of OPA. Regula's got some interesting stuff in it. So let's look up here. So down here on the left, you can see my list of this is just our GitHub repo. And you see we've got some libraries in here. Okay, let's look at fugue.rego. So, and by the way, you don't have to do stuff like this to use OPA. And if you're using Rego, we already did this for you. I'm just trying to show you the kinds of things you can do if you're trying to do something a little more ambitious.
Hey, Josh, quick question before you dive into this. There's a question around reusable or inherited components. So if you're trying to avoid redundancy in terms of your infrastructure as code creation, and you're going to basically pull or inherit pieces of infrastructure as code from somewhere else, does OPA, or how would you use Fugue or OPA to evaluate those lines of code?
That's an awesome question. So that's why Regula runs against the plan file. So if you're using Terraform, and by the way, as I mentioned, we're going to be doing this with CloudFormation, and CloudFormation has an equivalent interstitial step. So your HCL template is honestly, and if you're using modules and so on, I mean, we actually will with Regula interrogate all the inheritance in the modules at the plan file level, but the source code is not that helpful to doing this actually. It's just not descriptive enough. So that step when you do a Terraform plan, so let's say you've inherited a bunch of infrastructure as code from some internal sources and some stuff you found on GitHub that was approved, and you've pinned it all together, and you've written 20 lines of Terraform configuration, but you're inheriting 1,000 lines of Terraform configuration. The plan file is going to tell you the result of all of that in terms of the actions Terraform is going to take. That's why we operate against the plan file, not the source code. Also, the source code, Terraform is kind of a black box. It's not a real language again. It's not something you can like read and understand what's going to happen without running it. You have to run it to understand what's going to happen. And hence they produce that plan file that you can then interrogate using OPA, and that's what Regula is doing. So Regula doesn't care where you got your source code. It's going to tell you if the action you're going to take is going to yield correct or incorrect results. Did I understand the question? Did I answer it?
Yep, I think that's how I understood it as well, and I think you answered it. If there's any additional, I'll keep you posted.
Right on. All right, I'm going to refresh my beverage here. So this Fugue library, what we're doing here is abstraction, right? So this is what you do in languages. You take kind of lower level stuff, more machiney stuff, right? Stuff closer to the wire, and you abstract it into things that humans can understand. So we've got some really simple stuff in here, like resources by type equal, and then we've got some functions in here. So some declarations about what that means, resources by type. So if we go back to our rules in AWS, I think it was KMS rotate, here you see resource type. Well, that is an abstraction that we wrote in Rego, right? OPA didn't have to change OPA. We wrote it in the language Rego so that you don't have to worry about like navigating data structures to understand resource types. You can just say the resource type is a KMS key. These are the cool things you do when you have real languages. Okay, that you can do. Here we've got a bunch of other stuff going on, right? We've got a data.fugue library, and all this is open source. You can just download it and use it. And it's actually, if you want to learn to get fancy with Rego, it's a pretty good. I don't want to toot our own horn, but there's a lot going on in here you can learn from. There's a lot of pain that we have gone through that you can not go through. And so you can build up abstraction, and therefore you can express things very simply, and you can limit how much work you have to do. So this is the super simple one I've been using. Let's look at a little more sophisticated one. This is an IAM user attached policy. Here, resource type is multiple. You can see in all caps, we've kind of made that a reserved word in our library. Like, okay, the logic of the library is now going to change from a single resource type to multiple resource types. And we're going to, in here, do a bunch of interrogation of several resource types, the IAM user policy, the IAM user policy attachment, and the IAM user policy attachment, and the IAM policy attachment. If IAM doesn't confuse you, you're not human. All right. So anyway, we're coming up on time here. I'll just briefly show you how you can do OPA in our runtime. Your organizers, by the way, are like great about telling vendors like me that this is not a product pitch. I'm like, okay, it's not a product pitch. But I do want to show you just how you can integrate a custom rule. So this is just an OPA rule definition. Okay, it's the exact same code. You can also do it via API. Let's look at one I've already done. So here you go. Check for unused IAM roles, and this is the same code. So Fugue are all in on doing this in a completely open, standards-based way, open source way at least, and into OPA. So that's really what I had to show you today. Let's see if they gave me any other slides. They always get mad at me if I don't go through all those slides. Okay, here you go. It's just some links. So these are the websites I was showing you. These are the locations I was showing you. Oh, this automated infrastructure compliance framework down at the bottom is a partner of ours called NLT, who've done some really cool stuff. So that's another place actually to go and look for. They've written OPA that is not in Regula. That's part of their AI CF project. So I'll turn it back over if there's any questions or anything else I can cover.
Let's see. Any other questions in the chat? I think it's looking.
No, it's looking good.
No, yeah.
Very good.
You must be a super explainer, Josh.
Thank you. Some people are asking for the recording, so I think it's going to be a good thing to go back, because you've mentioned quite a few things from Regula, Frago, and just go back on the recording and see and understand all this. And like you said, invite people to play around with the project. So that's great. Any final word before we wrap up, Nikki?
No.
Oh, sorry, Nikki.
No, Josh, this is all you. You need to have the final word here.
Thanks for having me. It's been a lot of fun. It's one of the things I love about this business is meeting smart folks like you, and it's great to to get a chance to talk to you and show you things that we're passionate about. So thank you.
Awesome.
Cool.
Yeah, just before we go and wrap up, well, we're done, but I just want to invite you to register for our next event, which is next week, next Sunday. We'll be doing a 2-hour workshop on Checkov on how to check a similar topic, but for build time on how to check your infrastructure as code. So take a look. We're everywhere on social media, would it be on our meetup group, LinkedIn, Twitter. You'll find us and join us. So that's it for now. And thank you. And see you next week, maybe.